Hello, we're on 7.01 for Algebra 2, and we're going to talk today about right triangle trigonometry. So you guys talked a lot about this in geometry last year, and so we're going to start off with just some review of finding some sides and angles. So first, let's just review your SOHCAHTOA. So remember, it's really, really important that you spell SOHCAHTOA right. SOHCAHTOA. Sometimes you also write it like this. S is O, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If you don't remember what any of those letters stand for, make sure you include that in your notes. So S stands for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse again, T is tangent, and O again is opposite, and A is adjacent. All right, so let's use SOHCAHTOA. Oh, the other thing, this is only used on right triangles. So it has to have a right angle in order to use SOHCAHTOA. So here we have a right triangle, a 70-degree angle. This side is 12, and I want you to find x. So the first thing I like to do with these problems is I like to circle whatever angle is given to me, and then figure out what sides I have. So I'm going to label the sides with either an O, an A, or an H. So I always like to start with my hypotenuse. So I know the hypotenuse is always the longest side. It's across from your right angle right here. So this would be my hypotenuse. So I'm given that. I know the length of the hypotenuse. Now, I don't know this side, and I'm not looking for this side, so I'm not going to worry about it. Over here, that side compared to this angle, it's opposite from that angle. So that would be my O. If you have trouble deciding which is opposite and which one is adjacent, remember adjacent means next to. So if you were to trace the angle that you're looking at, one side will always be the hypotenuse and the other side will always be the adjacent side. You can never use SOHCAHTOA on the right angle. It has to always be one of your acute angles when you do SOHCAHTOA. All right, so now I have an O and an H, which means I look up here, and the more you write it out, the better, the more you'll remember it. So write SOHCAHTOA. So if I have an O and an H, we ask ourselves, which of these has an O and an H in it? And that's this first one, which is S, which stands for sine. So I'm going to write sine. It's always sine of the angle, cosine of the angle, tangent of the angle. So sine of 70 degrees equals opposite over hypotenuse. So the opposite side is x, the hypotenuse is 12. Whenever you're given the angle, then you put it over 1, and now you can cross multiply. So we get 12 times sine of 70. Please make sure to always write the 12 in front of the sine 70, or whatever this number is. It should go in the front. You should not write sine 70 12. Don't do that. Make sure you write 12 times sine of 70. And then at this point, you're just going to type it in your calculator. But I want to make sure you guys make a note here. Make sure you're in degree mode in your calculator. If you don't know how to do that, then you'd go to the mode button right here and make sure that it's in degree. So just hit enter on that and highlight that. Second mode will quit. And now I'm going to type in 12 times sine of 70. I'm in degree mode, so I don't need to put a degree symbol. And then I just write out my entire decimal here. So that's actually approximately 11.276311145. And it did not say it around here, so I'm just going to leave that as my final answer. Just write out the entire decimal that I see in my calculator. All right, let's do another one. So another right angle, so a right triangle. And we'll do this angle is 40 degrees. And this side over here is 9. And find x. So pause the video here and see if you can do that on your own. Since you guys did a lot of this last year, I'm hoping that hopefully with one example, it's coming back to you. All right, so again, circle the angle you're looking at that you're given. If you were given both angles, it wouldn't matter which one you circle. Just remember, do not circle the right angle. And label the side that you know and the side that you're looking for. So I know this side, so in relation to this angle, it's one of the two sides of that angle, which means it must be the adjacent side. And over here, it's across from the angle, so that's my opposite side. Let's write out SOHCAHTOA. Make sure we spell it right. The more we write it, the more we remember it. Now, which of these has an O and an A in it? No, no, yes. So we want to use tangent. So tangent of the angle, sine of the angle, cosine of the angle, tangent of the angle, must be an angle next to that, equals our opposite side, which is x, over adjacent, which is 9. Then go ahead, put this over 1, and cross multiply. So we get 9 times tangent of 40 equals x. Put that right into your calculator. Again, you would just type in 9 times tangent of 40, and then write out your full decimal and round to the near, oh, this actually doesn't say to round, so we're going to leave it just like that. All right, let's do one more of these. So we've got a right triangle, which we need in order to use SOHCAHTOA. 50-degree angle. Next, pause the video here and solve for x. This is a 50 down here. All right, so again, you guys should have circled your angle, labeled your two sides. So this is the longest side. Across from the right angle is the hypotenuse. The 6 is next to the 50-degree angle, so that's the adjacent side. Write out your SOHCAHTOA. You could also write it like this, if that's how you're comfortable. And here I have an A and an H, so that's cosine. So I'm going to use cosine. It's always cosine of the angle, sine of the angle, tangent of the angle. So cosine of 50 degrees equals adjacent, which is 6, over x. Again, put it over 1 and cross multiply. This time I have an x. So again, the x goes in front of the cosine of 50, not after, equals 6. Now I need to solve for x. So to get rid of this cosine of 50, x is being multiplied by it. So I want to divide both sides by cosine of 50. And then, again, we're going to go straight to our calculator, and you can use your alpha y equals here and do 6 over cosine of 50. And then write out your whole decimal. And that's the process you want to use whenever you are finding a missing side of a right triangle. The other thing we always have in our back pocket to use is Pythagorean theorem, and that also only works on right triangles, but that would be if you are given 2 out of the 3 sides. So the difference here is that we only know 1 out of our 3 sides in these problems and one angle besides the right angle. So really we could find all 3 angles pretty easily here because we know they all add up to 180. So you need to know the angle and you need to know at least one side. So one of the acute angles and one side. All right, now let's talk about, so this actually, I'm going to go back to here one more time. These ones were solving for a missing side, just to label that on your notes to make it a little easier to find in the future if you need it. And then we're going to do solving for a missing angle this time. Okay, so the same idea here is we want to find the missing angle, and you're going to start by circling the angle you're looking for and labeling those given sides. Again, you guys should have done this last year. There's one extra thing we are going to talk about this year, which is something called degrees, minutes, and seconds. It's another way of measuring the angle. to be more specific. It is used in navigation a lot. We're not going to do a whole lot with converting it besides just using our calculator to do so. But it's number 4. So for each of the following triangles, find x to the nearest minute. And that's something that'll be new. All right, so let's do letter A first. And then I've got a couple other things I'll add on for your notes too off to the side here. So first, let's draw our picture. It's a right triangle. This time you know 2 out of the 3 sides, and you're looking for x, or a lot of times we call it theta too, which looks like a cursive O there. Okay, so we're looking for x. So first step you want to do is circle the angle you're given. After we do that, so we identify which angle, label your sides with O, A, and H. So you should have 2 out of 3 of those. Even if you have 3, that's fine. You can choose whichever 2 you want then. And then decide on your trig function. So meaning decide on whether you're going to use sine, cosine, or tangent. All right, so now I want to circle this angle and label my sides. So I have the 4 is adjacent to the x, it's next to it. And the 3 is across from it, so that's opposite. Neither are the longest sides, so no hypotenuse here. So again, let's write out our SOHCAHTOA. And I have an O and an A, so I look for which one has an O and an A, and that's this one. So I'm going to use tangent. So tangent of the angle. Now my angle's x, so it's going to be tangent of x equals opposite, which is 3, over adjacent, which is 4. Now, really important to keep in mind if you're finding an angle or a side, because when you're finding an angle, you do not want to put it over 1 and cross multiply, because we need to solve for this x, and that's not going to help us to do that. So whenever you're looking for an angle, you should always be using your inverse trig functions. So that's those ones with the -1 on them. So we're going to do, since it's tangent, we're going to do tangent of -1 of whatever you have this set equal to. And what that does is it kind of like separates your tangent and x. So it allows you to solve for x that way. And that's the only way that you can get x alone, is by using that inverse tan, inverse sine, or inverse cosine button. So in your calculator, again, you want to make sure you're in degree mode, and then you're going to hit second tan. So the -1s are all above sine, cosine, and tangent. And then I'll type in my 3 over 4. Whoops, second tan. And you can do your alpha y equals in here, 3 over 4. And then just write out your entire decimal for that problem. So we get x equals 36.8698975. So I'm just going to make a note over here. Whenever you're finding an angle, you always want to use the inverse trig functions. One of those 3. All right, now let's talk about degrees, minutes, seconds. So degrees, minutes, seconds. DMS. Okay, so to get to this, make sure you have this in your calculator, the inverse tan of 3 over 4, because you're going to want that decimal. You're going to go to the angle menu. So to get to the angle menu, it's second apps right here. So it's next to the math button is apps. And what you'll see here is listed, the first number 1 is the degree symbol, and number 2, it looks like a little apostrophe, that's your minutes symbol. So what we know about degrees, minutes, and seconds is that 60 minutes, so that 1 apostrophe there, that means 60 minutes, and that's equal to 1 degree. And we know 60 seconds just like with time. So the like a little quotation marked, so double lines, that means 60 seconds, and that's equal to 1 minute. Now, so this one is easy for us to remember. 60 seconds equals 1 minute, and 60 minutes equals 1 degree. So when I type this in, I already have this here. So I actually want to go down to where it says DMS, which is choice 4, and then hit enter again, and it converts it automatically for me. So what on your calculator, so here we did second apps number 4, which is DMS. And now what it says is 36 degrees, 52 minutes, and 11.632 seconds. So to round to the nearest minute, and here's where it's a little bit different than our normal rounding rules. So if I want to round to the nearest degree, let's say, and this is what I was given, then since 60 minutes are in a degree, our rule is usually half or more, we round up. So half of 60 is 30. So if you are 30 or above, then you would round this to 37 degrees. If it's below 30, then you would keep it 36 degrees. Same thing rounding to the nearest minute. So you're going to look at how many seconds you have. If you have less than 30 seconds, you're going to keep the 52 minutes. If you have more than 30 seconds or 30 seconds or more, you would round up to 53. So this one is less than 30. Therefore, you're going to keep it. Make sure, though, one of the issues that students have is they forget to write the 36 degrees still. They only write the 52. You still have 36 degrees. It's just how much more than 36 degrees, which is 52 minutes. So our final answer would be 36 degrees, 52 minutes. So here, I'm just going to make a note that I'll put it below here. So if you have 30 minutes or higher, you round up. And if you have 30 seconds or higher, you also round up. Okay. Let's try another one. Another right triangle. So actually, let's make this theta. So it's like a little circle, an O, like a cursive O. The hypotenuse is 3, and this side will be rad 3. All right, so we will start by circling the angle, labeling your sides. Go ahead, pause the video, and see if you can find this angle on your own and convert it into degrees, minutes, seconds, and see if you can even round it to the nearest minute. All right, so over here I have my opposite side and my hypotenuse. So if I have SOHCAHTOA, then I have an O and an H, which is sine. So I'm going to do sine of the angle. So sine of theta equals opposite, which is rad 3, over hypotenuse, which is 3. Since I'm looking for an angle, that's what's missing. Anytime I'm looking for an angle, I want to use inverse sine, inverse cosine, or inverse tangent. Since we're using sine, it's going to be inverse sine of whatever we have it equal to. So inverse sine of rad 3 over 3 will give us theta. So I type that into my calculator. So I do second sine of rad 3 over 3. And write out my full decimal. So 35.264388968. Now, to switch it to DMS, which is the new part here, we would do second apps number 4, hit enter, and now I'm going to write that out. So second apps number 4 gives me 35 degrees, 15 minutes, and 51.803 seconds. Now, one thing I didn't mention before, that if I asked you to round to like the nearest second, then normal rounding rules apply. So then this, if it was to the nearest second, it would be 35 degrees, 15 minutes, and 52 seconds. But this said to the nearest minute, which means we need to look at how many seconds we have. So 51.8, which means it's more than 30. And if we're more than 30 seconds, we are going to round up. So our final answer would be 35 degrees, 16 minutes. Again, I want to remind you to make sure you write the 35 degrees. We're not just saying 16 minutes. It's like if you were rounding 2.35 and I asked you to round to the nearest tenths place and you told me the answer was 0.4. That's not right. You have to still have the 2. It's 2.4. Okay, so that is finding a missing angle with degrees, minutes, seconds. Now we're going to talk about something new, which is your reciprocal trig functions. So up until now, we've only had 3 trig functions. Now we're going to talk about 6 different trig functions. And they're all related. So we still are using our SOHCAHTOA. So over here, we're still going to have sine of your angle equals opposite over hypotenuse. But now we also have another one, which is the cosecant of theta. So the cosecant of theta is the reciprocal trig functions. So the reciprocal functions are just what that says, reciprocal. So instead of opposite over hypotenuse, it's hypotenuse over opposite. Now these do have to be memorized. So one way we try to remember it is that we always say C's and S's go together. So if one starts with an S, sine, its reciprocal starts with a C. So for cosine of theta, which we know is adjacent over hypotenuse, its reciprocal starts with an S, and this one's called secant of theta. And that one will be hypotenuse over adjacent, so we just flip it. And then, of course, we have tangent is opposite over adjacent. That one is not an S or a C, but it's easier to remember. This one is called cotangent. And that one, again, you would flip it to be adjacent over opposite. So you need to know all 6 of these trig functions now. All right, we left off on 4, so this will be number 5. So for number 5, I'm going to give you a right triangle, and we'll call this theta. This is 10 and 5. So first thing I want you to do for number 5 is find the missing side. So let's call this triangle cat. So find the missing side, AT. So go ahead, pause your video and see if you can find that. Hopefully you realize that you had 2 out of the 3 sides of a right triangle, so you can use Pythagorean theorem. So we would take 10 squared plus 5 squared equals our AT squared, and that gives us 125. Take the square root of both sides, and we'll put it into simplest radical form. So we know we can take out a 25, always write the perfect square first, times rad 5 equals AT, and then the square root of 25 is 5. Okay, so we know AT is 5 rad 5, so I'm going to put that on our picture. So now I want you guys to help me evaluate the 6 trig functions of theta, and I want them all in simplest radical form. SRF is simplest radical form. All right, so let's start with sine. So first, if we take sine of theta, let's go up here and circle theta. So sine of theta, and actually let's label our 3 sides. So across from that is our opposite, next to it is adjacent, and our longest side is our hypotenuse. So sine is opposite over hypotenuse. So that would be opposite is 5, and the hypotenuse is 5 rad 5. Now we never want to leave a radical in the denominator, and we want these all to be reduced. So my 5s I see can cancel, leaving me with just a 1. And then I want to multiply the top and the bottom by rad 5, leaving me with rad 5. Rad 5 times rad 5 is 5, so rad 5 over 5. Okay, and then if I go over here now, I'm not going to do cosine, I'm going to do the reciprocal of sine, which is cosecant of theta. So cosecant of theta is the reciprocal. So if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. So we go here, our hypotenuse is 5 rad 5, and the side opposite from theta is 5. And then we can cancel out our 5's, leaving us with just radical 5. All right, I'd like you guys now to try the cosine of theta, so that we know is our adjacent over hypotenuse, and its reciprocal. Remember, C's and S's go together, so the reciprocal of cosine is this one, which is secant. So I want you to find both of those. Pause the video, go ahead and do that now. All right, so for cosine is adjacent over hypotenuse, so that would be 10 over 5 rad 5. So 5 goes into 10 twice, so we have 2 over rad 5, and then we want to rationalize it by multiplying by that radical on the top and the bottom. So we get 2 rad 5 over 5. For secant, you should have done the opposite, so hypotenuse over adjacent. The hypotenuse is 5 rad 5, and the adjacent side is 10. And then again, we can reduce to get rad 5 over 2. Okay, and then lastly, we'll do tan and cotangent. So tan is our TOA, opposite over adjacent. And cotangent is the reciprocal of that, so adjacent over opposite. Take a moment to find both of those. All right, so tangent opposite is 5 and adjacent is 10. So that should have given you 1/2. And then we flip it, adjacent is 10, opposite is 5, which gives you 2. So those are your 6 trig functions. And again, this right here is called theta. I know some of you are not as comfortable with theta. Okay, next we're going to briefly just talk about what a Pythagorean triple is, which you've probably heard in geometry, but just to make sure you know what it is as we talk about right triangles. So Pythagorean triples means that you have 3 natural numbers, meaning counting numbers like 1, 2, 3, 4, 5. So no decimals, no radicals, that they have to satisfy, to be a triple, that it must satisfy Pythagorean theorem, meaning there's 3 numbers that form a right triangle. So for example, the one you guys probably know the best is a 3, 4, 5 triangle. So the 5, the longest side has to be our hypotenuse. So if you squared 3 squared plus 4 squared, that would give you 5 squared. So 9 plus 16 equals 25. So it satisfies Pythagorean theorem, and they're all nice integer numbers. So one Pythagorean theorem that we know the best is 3, 4, 5. Another one we know is 7, 24, 25. So 7 squared plus 24 squared will give you 25 squared. Another is 5, 12, 13. It's nice to know these because then you don't have to do Pythagorean theorem if you recognize the sides. And I didn't do this one. 8, 15, 17 is another common one. So those are just ones that I'm giving you to recognize. Another really cool thing about a Pythagorean triple is that any one of these that you take, you can multiply it by any number. So if I took this and I multiplied it all by 2, it would give me 6, 8, 10. That's another Pythagorean triple. So you can multiply this by any natural number and it'll give you another right triangle, which I think is pretty cool. All right, next up, we're going to talk about how to use the calculator with some of these reciprocal trig functions. So use the calc with reciprocal trig functions. And we're also going to talk a little bit more about that DMS, degrees, minutes, seconds here too. So first of all, make sure you're in degree mode. Super duper important. Okay, so use the calculator on all of these. So We'll do the first one is cosecant of 60 degrees. So we said before that this is a reciprocal trig function. So if you have cosecant of 60 degrees, we do not on our calculator have a cosecant button. We have a sine, cosine, tangent, and then we have the inverse trig functions. Now, inverse trig functions are not the same as reciprocals. So reciprocals means you're flipping it. Inverse is only used when you're finding the missing angle. So cosecant of 60, in order to find that, since we know it's the reciprocal of sine, and we're already given the angle, so we know it would be hypotenuse over opposite, we can actually flip the entire thing. So we can write this as 1 over sine of 60, but here's where it's so important that you memorize which ones go together. So C's and S's go together. So we would now just type in 1, alpha y equals 1 over sine of 60. And then you would write out your whole decimal. And later on, we're going to talk about how to get exact values of ones like that too. And that's it. Let's try another one. So cotangent of 57 degrees, 45 minutes, and 30 seconds. Okay, so cotangent, we need to recognize we don't have a cotangent button. So what's the reciprocal of cotangent? Well, and if you need to, go back to this. The reciprocal of cotangent is tangent. So we know they're reciprocals, which means to type it in our calculator, we want to do 1 over tangent of 57 degrees, 45 minutes, and 30 seconds. Biggest mistake with these is that students try to flip the angle. So students will try to write like sine of 1 over 60, things like that. And that will not work. You're never going to flip the angle, like make the angle into a fraction. You're only flipping the entire thing when you're given the angle. And if you're looking at the ratio of it, like opposite over hypotenuse, then you just flip that to hypotenuse over opposite. So now here, when we type this in, we're going to do alpha y equals 1 over tangent. So here's where it gets a little tricky because we have minutes and seconds. So I'm going to type 57, and then I'm going to go to second apps. I'm going to hit enter for degrees. Then I'm going to type in the 45, second apps again, this time go down to minutes. And the last part's tricky because it's 30 seconds. So you're going to type in 30, and seconds is actually not in that menu. To find seconds, you're going to go over here and do alpha plus sign. So it's right above enter, and you have to hit the alpha button to get it. You can see it above that key. On mine, I think it's a little blurry. And then hit enter and write out your decimal. So to type those in, you're going to second apps for degrees, number 1. This one's number 2. And then for seconds, it's alpha plus sign for seconds. And we get 0.63074968844. Okay, and let's do secant of 80 degrees, 30 minutes, and 5 seconds. Pause the video here and type that into your calculator. All right, so you guys should have typed in 1 over cosine, C's and S's go together, 80 degrees, 30 minutes, 5 seconds, and you should have gotten 6.059735751 for your answer. All right, so that's typing it into your calculator. And now we're going to just talk about solving a right triangle for our last thing here. So to solve a right triangle means you want to find all 3 sides and all 3 angles. So you're just finding everything. One thing that I want to go over first is when we talk about triangles and labeling them, things like that, you want to make sure that when you talk about the angles, we're always using capital letters. And when we talk about the sides, we use lowercase letters. So if this is angle A up here, capital A, across from it would be lowercase a. If this is capital B for the angle, across from it would be lowercase b, side B. And across from angle C would be lowercase c. All right, so when we solve a triangle, important to remember that you always draw a picture. And this is really important. Always use the entire decimal to find other values. Don't use rounded values to find another part of the problem. Only round as your last step. And with these, there's always more than one way to set them up. So don't be scared to just kind of dive in. All right, we are on number 7. So solve triangle ABC, given that capital B is 24 degrees, lowercase a is 8, and I'm going to give you a picture here. Or I could have told you, just said to you that angle C is the right angle. All right, so first thing I want you to do, pause the video and label your triangle. So find angle B and side A. So here we should have 24 degrees for angle B, and side A is across from angle A. So over here is going to be 8. So I need to find the rest of my sides. So I know that this is side C and this is going to be lowercase b. First thing that maybe I want to do is find the missing angle. So I need to find this angle. I know all 3 angles add to 180. So I can start by just subtracting 90, subtracting 24. You can do that right in your calculator. Gives us 66 degrees. So that's the measure of angle A. So now I've found all 3 angles. 1, 2, 3. So now I just need to work on finding the 3 sides. I know 1 out of the 3 sides. So again, there's lots of different ways you could set this up. You can use either of these 2 acute angles. My personal preference is to use the one that was given, just in case I did addition or subtraction wrong here. So I like to use the one that's given when possible, and I also like to use the given side as much as possible. So I know this side is adjacent to that angle, and maybe we'll find side B first. So that's opposite from that angle. So now I have an O and an A, so I'll write out my SOHCAHTOA. And if I have an O and an A, that's tangent. So I'm going to set up my tangent. Pause the video, see if you can set it up and solve for B on your own. After you solve for B, see if you can go ahead and solve for C as well. All right, so it's always tangent of the angle. So tangent of 24 equals opposite over adjacent. So that would be side B over 8. Now I want to cross multiply whenever I already have the angle. So 8 times tangent of 24 equals 1 times B, which is B. Type that right into your calculator. And write out your decimal. Now this doesn't say to round, but if I was using this side B to find side C, let's say, then I would have to use that entire decimal, even if it had said to round my final answers. So at this point, some students ask if they could use Pythagorean theorem, and that's fine to use. But again, I wouldn't recommend it because you'd have to use this entire decimal into your Pythagorean theorem. I think it's easier to then just set up now and say, okay, well, I have the adjacent side, and here's the hypotenuse. So now I can use cosine of 24 and do adjacent, which is 8 over C, side C. Put it over 1 and cross multiply. This time I want to solve for C, so I want to divide both sides by cosine of 24. Type that into your calculator. And if you want to use a different letter there too, if you don't like the 2 C's, that's okay. Just make sure it's labeled 0.757090228. So now we have found all sides A, B, and C, and all three angles, angle A, angle B, and angle C was 90. And that's how you solve a right triangle. All right, and that is it. I know this was a long lesson, a lot of information, a lot of review, but also a lot of new stuff too. So if you do have any questions or concerns, be sure to let me know. And I hope you guys have a great day, and pie out.